Welcome to Assisted Lab 2 for week 1, day 3, scanning and identifying network nodes. In this activity, you will use common network tools such as local commands and the Nmap network mapper to discover other hosts on the local network. Next, you will conduct a banner grabbing exercise to identify specific services on the hosts. Finally, you will use DNS tools. You'll use DNS tools to gather name resolution information. So determine the configuration of the local host and its subnet using tools such as ifconfig, IP, ARP, netdiscover, and pathping. And run the scans from the Kali Linux VM and the DC1 Windows server. Okay, so we are in PT1 Kali. Yes, we are. Sign in as root. Come over here. ROT, tab, and it's capital PA, $, W0RD. Logging in. There we go. From the top bar, select the terminal emulator icon. Back up. There we go. And there we have it. Run the ifconfig command to display the interface configuration. Note the IP address assigned to the ETH0 interface. So we're doing ifconfig. IP has replaced the ifconfig command, but we're going to do exactly as it tells us to do. Ipconfig is what you use in PowerShell. So it's ifconfig. Right. Just that one command, nothing else. Right. What is, note the IP address assigned to the ETH0. Where are you at? There it is. 10.1.0.192. There it is. Run the IP command to display the same information. So just do IP, and then we're using the option A. Also. Okay, so we're down here. So just IP. Dash. Okay, no dashes, no nothing. There we go. Tells us basically the same thing. 10.1.0.192. Okay. 10.1.0.192. My computer remembers from the last time I did this one. Right. And here, in case you didn't know where to find it, it looks like if you scroll down just a little more, it shows you where to go. All right, so now we're going to run the following command to identify the default gateway, the router. Okay. No hopping, it's just going to tell us here. Okay, so IP route show. We're going to show the IP route, and there it is. 10.1.0.254. Because the local network uses DHCP to provide client addresses, the local machine has been configured with the default gateway address automatically. So here it is. It is 10.1.0.254. 10.1.0.254. Score. There it is. And again, if you had some trouble. Now the ARP command with, so the ARP command with the dash lowercase a option to check the ARP cache to display other hosts local to this subnet. All right, so we can come back over here. ARP. Oops, boy, that's too many P's, isn't it? Okay, ARP space dash lowercase a. Go. So what is the IP address for the dc1.corp.515support.com virtual machine? Well, here it is, 10.1.0.1. Okay, so it's showing you here too, 10.1.0.1, just in case. 10.1.0.1. Now we're going to run the IP neighbor command. Okay. Howdy, neighbor. To display similar information using the newer IP tool. Okay, so IP NEIGHBOR. Okay, so there it is. Dev ETH0 proto L ladder. Okay, so the ARP cache shows only machines that have communicated with the local host. To verify whether any other hosts are present, you can perform a sweep of the local network. One means of doing so is to use ping in a for next loop. You can also use the NetDiscover tool bundled with Kali. So what we're going to do is we're going to actually run the NetDiscover. Okay. So for those of you who have not taken Linux before, this first is called the command, NetDiscover. All right. So the next thing that we're going to see is what's called an option, and they all have different meanings. So right here, don't worry about what they mean right now, but now we're going to do the option of dash lowercase I. Okay. And what are we going to be looking for? ETH0. And dash R looks like route 10.1.0.0. Oh, okay, hold on a second. Number lock 10, there we go. .1.0.0/24. Right, so NetDiscover I ETH0 R 10.1.0.0/24. May take up to 2 minutes. Let me run that. Okay. So we're going to let it actually get some stuff. Can wait to see how many hosts were found by NetDiscover. Just give it a minute or 5. No more than 2. Right, so I'm going to call this one good, and let's see, if I press Q to quit, that's what I did, so I'm all done there. So we got 1, 2, 3, 4, 5. It found 5. 5. There we go. So, yep, it looks like that. And I pressed Q to exit and return to my command prompt. Now we're going to run NetDiscover-H to view the help page. The tool can operate in passive mode, but you do not have to be stealthy. So you will run an active scan. So here we go. NetDiscover-H. This is giving us lots. All right, so here we're looking at Net Discover. We went up here and we did I and R. I means device, your network device. I was ETH0. And then R, range. Scan a given range instead of auto scan. So it gave it a range right there. So this just help. And there's other things that you can see there. Time and node and enable and print, all kinds of things. So now we're going to switch to the DC1 VM. So we're in PT1. So let's switch to DC1. Control-Alt-Delete. All right, so there we go. We are administrator. Here's the password. Go. All right. Going to scroll down, scroll over, right-click Start, select Command Prompt, Admin, and then Yes. All right, so now we're in Windows now. So the command in PowerShell with the command prompt is ipconfig. Boom. Okay. What is the IP address for the DC1 virtual machine? There it is, right here. IPv4 10.1.0.1. 10. Oops. Better put number lock on. Here. 10.1.0.1. Cool. Yeah, in case you didn't know, it's showing you. Now run the following command to test the reliability, packet loss, and latency delay of the connection between the DC1 VM and the PT1 Kali VM. So path ping is the name of the command. What are we pinging? 10.1.0. Let me see if it'll do the whole thing. No. So path ping space. Nope, I'm going to have to type it all in. 10.1.0.192. Do its thing. We're going to look at the percentage of packets were lost during the test. Get the statistics going here. Computing statistics. There we go. All right. Trace complete. 0%. 0%. Let's see. Lost sent packets. There we go. The two machines are not very far apart on the network, on the same subnet in fact. If you're running path ping against network nodes that have several routers between them, the utility displays lost packets along the route, which helps to clarify where network communications might be unreliable. For example, from a Windows computer with internet access, you could run path ping 8888 to trace the route to the servers running Google's DNS service. Note that the lab virtual machines does not have internet access, so there's not a whole lot that we can do about that. But let's use Nmap to discover hosts. From a penetration tester or threat actor perspective, network reconnaissance will typically aim to discover the following. The default gateway, that's the router connecting the subnet to other networks. The DNS server, that's used to resolve the host names on the network. whether any network directory, authentication, and application servers are present, whether any host client access devices are present, and whether any other types of devices, embedded systems or appliances, are present. So we're going to use Nmap for the PT1 Kali VM to report this information. So we're going to switch back to Kali, and we're in, and we're going to run the following command to scan. Let's come over here and click clear, enter, gives us a nice clean one. So we're going to do Nmap localhost. Nmap localhost. Okay. So what port is open on the virtual machine? Well, it's 22 TCP. It's open. And it's a secure shell. 22 TCP. Boink. See if you have any. Yeah. You can assume the SSH server is probably running. Now we're going to run the following command to do a basic network scan. Okay, so Nmap. And what are we going to scan? We're going to scan this range, 10.1.0. Oh, that's right, I got to go back in and press my number lock on. 10.1.0.0/24. Use the following chart as a reference for Nmap options during this activity. Yeah, so here are the options. Remember I was telling you, first you have your command. Nmap is the command. Then you have some options, and they are case sensitive. So no option at all is just your basic scan. So Nmap space 10.1.0.0. You can use a capital A for OS port service detection, or dash lowercase uppercase s for a fast scan, dash lowercase p specified port numbers, and dash dash top dash ports 20. So this one scans the top 20 common ports. You can change this number. Then lowercase s lowercase n with the dash scan for up down hosts. So we're going to be referring back to this here. So we're going to run the following command and check the output. What services are running and what do they tell you about the host? All right, see, remember with the lowercase s and uppercase s dash, right, this one is the fast scan. Okay, so our command is Nmap, and our option is lowercase s, uppercase s. And what are we going to scan? 10.1.0.254. Go. All right, so we got port 22, port 53, both are open. One is for a secure shell, the other one's for the domain. What services are running on this virtual machine? Well, we've got the secure shell and the domain. So secure shell and the web service. This one is the making sure that the name matches. Oh, what did I get wrong? Really? Okay, the DNS server domain. My bad. Usually when you have domain, it means and it's 53. It's web services. Oh my. All right. So technically this is, because this is 53, it's domain, not DNS, but that's the one that they want. All right. Run the following command to identify more about the host. We're going to do Nmap is the command. This uppercase A dash uppercase A, go back up here, OS port service detection. All right. So here we go. Get nmap, oops, nmap dash uppercase A. And what are we going to scan? 10.1.0.254. Go. Okay, there we go. Service info, operating system. This is what operating system is running on the 254 host. The operating system is Linux. There it is. Okay. Now run the following command to scan for open ports. This is port in the port range. Okay, so now we'll go over here again. Let's clear it. Okay, so nmap again. And this time we, oops, back here. And lowercase p. I'm scanning for ports 20 through 200 on 10.1.0.0/24. Give it a second. There we go. I'm looking on MS1. I have to scroll up a little bit. Keep going. Okay, so here is the top of it. So we're looking for, is port 80 open on MS1? Port 80, but is this MS1? Okay, yep, here's the MS1. Port 80 is open. Yes, it is. Okay. Now we're going to run the following command to scan for the 20 most common ports. And that's what this is, top ports. Here's 20, but you can also do 10 or 5 or 100 or whatever. And this is what we're going to scan. Let's come back down. Let's clear it again. There we go. Actually, what I'm going to do is I'm going to press up. See, and this still has the 10.1, so I'm going to actually just start deleting here. Okay, so it's dash dash top dash ports. How many? 20. All right, and I'm going to press N to go. So what I did is I pressed up and then up again for my history. Right, for the history to find one that was similar. And because a lot of this is the same, I didn't want to have to type it in again and again. So nmap space dash dash top dash ports space 20 space 10.1.0.0/24, enter. And there they are, the top 20 of them. It tells us the service. This one's for DC1. Let me see. Give me your mousy mouse. Okay. That's for DC1. I scroll down a little bit. MS1. Okay. All right. There we go. Now we're going to run the following command to quickly scan the network for hosts that are up or down on the network. So that's what this dash SN. Scan for up-down hosts. Okay. Okay, get back over here. down. Okay. So again, see, I just press up, and that gave me the last thing that I typed in, and now I can just go like delete. Okay, so it's dash SN, and then press N to make sure, nmap dash SN 10.1.0.0/24. Go. Okay. Which server is configured as an email server? Hint, you'll need to look for the default SMTP port number in the ports used field of each host. Okay, so we need to go up to, so here's the beginning of our command. Okay. Local directory, not scan for DC1. Looks like it's DC1. No. Dip it. And map. Oh, let me come up here. Okay, SMTP. Let's pop and pop. Oh, okay, so this one, it is definitely filtered. Looking up here, keep going. MS1. Yeah, I had to go up. I had to go up to once. Okay, so there it is. Oh, and it tells you in the scan report for MS1. Yep, you had to go up because the one that they just did is not the one that's going to tell you. You had to actually go up and look for it. Okay, here we go. Banner grab with curl and Firefox. Okay, curl is a Linux command that you can access the internet without a browser. Pretty cool. Banner grabbing is a way of identifying service versions. This information helps attackers select potentially vulnerable machines. The information also helps administrators confirm that all services on the network are of a certain version. Basic tools can be used to grab banners. In this activity, we're going to use curl and Firefox. All right, so we're in the terminal. So curl, S, lowercase s, uppercase I. Okay. Don't worry about what these commands mean right now. Just know that this is command, and we got more than one option. Okay, so curl, dash lowercase s, space, dash uppercase I, space, 10.1.0.1. Curl si, go. Okay. That's okay. What web server service and version is used on the target VM? Got HTTP one. Oh, here it is. Server Microsoft IIS 10.0. This one. Okay. Yep, 10.0 score. All right. You used port scans in the early activities to determine that the 10.1.0.1 virtual machine is running a web service, even though it said that has DNS in that one, but it's web service. With this curl command, you have determined the software type and the version for the web server service. So in Kali, here we are, we're going to type Firefox and HTTP. All right, so here we go. So the command is Firefox and HTTP : // 10.1.0.1. Okay. What web server service is used on the target VM? And so again, IIS Windows Server. But, okay. Microsoft one is Internet Information Services, though this is not sort of thing. So, yeah, Internet Information Services. Not Apache. There it is. Close the Firefox web browser. Oh, there it is. Internet Information Services. Toodles. Okay. Now we're going to query the DNS. DNS provides name resolution to internal networks as well as the internet. DNS is used anytime. Oh, yes, I do want to expand it. Thank you. DNS is used anytime a user or application refers to a host by name. DNS queries name records to find the IP addresses associated with a host name or fully qualified domain name. These name records can also reveal information about how a network is configured. In this task, you will gather DNS information by using the dig utility. Okay. So run the dig command in the terminal to perform a reverse lookup on the default gateway. That's probably what the X means. So here we go. Clear it. Dig -X and the 10.1.0.254. Okay, dig. Was it Debian? Got answer. What is the IP address of the DNS server that answers the query? Right, so here's the question. Query, status, ID, flags. What are we looking for? The IP address. Query, server 10.1.0.1. 10.1.0.1. Yeah, here it is. Score. Okay, use dig to answer the following question. What is the fully qualified domain name of the VM found at 10.1.0.2? Okay, the trailing dot. Okay, use dig to answer the following question. Because we did this one for 10.1. So for the options for this command. And the fully qualified domain name. Let's try this. Going to go up like that. And we are going to actually go 10.1.0.2. Enter. Answer. Here it is. ms1.corp. Okay. Yeah. ms1.corp.515support.com. Okay. Here it is. So optionally run dig-h. Dig-h. There we go. So let's give you all kinds of things here that you can kind of goof around and look at it. So we're using X, shortcut reverse lookups is what we did. Okay, so here we go. Now we're going to run the following command to display the authoritative DNS server for the namespace. Okay, dig SOA. Let me see if they, yeah, I'm not going to bore you with that. Dig SOA. So here we go. dig SOA corp dot 515 support.com. Okay. Display the authoritative DNS server for the namespace. There it is, 10.1.0.1. Okay. Secure, okay. The query returns the fully qualified domain name of the DNS server responsible for the domain. There it is, dc1.corp. Right, so SOA. And its host record. There it is, 10.1.0.1. It's also worth noting some of the flags shown. AA indicates that the answer is authoritative. Okay. There's AA. Looking around in the answer section. Oh, there we go. Flags. AA. Answer is authoritative. The authority section of the response is empty. Contents for this section are commonly omitted by name servers to reduce the size of responses. And then RA here indicates that recursion is available. That is, this router will forward queries to other services. So close the terminal window. Bye. Me or you? Right. Now let's look at the questions. Which of the following answers correctly summarizes the steps in this activity? All right, did we identify the Kali Linux and Windows servers, perform basic scans of network, identify hosts and services, use banner grabbing to identify services, gathered more DNS information, cracked the domain administrator's password? No, we did not. Use a phishing attack to gain? No, we did not do that either. Identified the Kali Linux and Windows servers, broke the network's wire? No, we didn't do any of that. We just did this one right here. Okay. Which of the following answers best identifies how an administrator might use the information gathered during this activity? Audit passwords, verify expected network and server configurations, troubleshoot internet access, or to configure centralized logs. No, this is to verify expected network and server configurations. And then finally, which of the following answers best identifies how an attacker might use the information gathered during this activity? All right, map network in preparation for attack. Yeah, all right, so didn't check for old services that may be unpatched, no. To map the network in preparation for an attack, I think you might be able to do that because they use nmap. It's a very powerful tool. We did not crack any passwords. We did not launch a phishing attack for passwords, but we can decide what servers to attack because, oh, no, don't do those. To decide what servers to attack because then you would be able to see what ports are open. Try again. Oh, select 3. Okay, let's try that one. No. Try that. There we go. Check for old services. Okay. All right. Old services. That makes sense. All right. So when we're looking at the services, you're looking at the ports and seeing that the services that are open or closed or filtered, they would be able to take a look and see which services that are there. Ooh, look, that's an old service. Okay. There we go. Grade the lab. Submit. Yes, I'm sure. Let's do it. Yay! And there we have it.